Hi everybody. So I was super bummed I was going to be re-recording this video for you when I found out on Saturday in like the middle of the day playing with my kiddos. But today I'm like kind of pumped to be re-recording this video because I know when I first recorded this, I thought this lesson was so hard. And now I absolutely believe it's within our kids' grasp and it's not even a thing. Like I've seen first graders use compensation and it's so powerful as long as it makes sense. And so what are the tools we use to make sense of stuff, right? We use the concrete. It starts with the concrete, right? Then we move from the concrete to the pictorial to the abstract. And if you do that, they will be fine. And it's not just a lesson about mental math, like eventually being able to do this in your head. It's actually a powerful lesson that what we do concretely matches what we do abstractly. Like, fine, when we add 2 plus 3, they can get it. But what about when we add 218 plus 100 minus 1, right? That is legit, like a movement we can make with cubes is pretty powerful. And I think kids still don't get that concept. And so I'm excited about this day. So for each of the addition problems, we're going to find a number that's close and would be easier to add. We've been doing mental math, right? And so we know how easy it is to add some of these in our head. We call this a friendly number, a compatible number, right? So here, like 54, gosh, wouldn't it be so much easier if I added 30? Yeah. Or 54 plus 28, easier to add 30. 54 plus 38, it would be easier to add 40. Great, they're helping you with this, right? 328, it would be easier to add 19. Or, 20. Just testing you. It would be easier to add 20. It would be easier to add 60. Okay, so we all agree there are like easier numbers to add. Okay, let's think about what this looks like if we add it. And that's when you get out your blocks, right? Your new fixed cubes. You build 2054. You're building these. Here's your 54. I want to add 29, but instead I add 30. I just need to do one little thing to make this into 29 again, right? What's that one little thing? A kid is going to say it. They're going to say, break off a cube. And you're going to be like, right. All I need to do is be like, boop. Right? And now I've added 29. 54 plus 30 is easy. 54 plus 30, 84, right? And then minus a cube, this is really, 83. So I just have to do that. And I can see that this and this are the same. So I'm really, I could set it up like this, right? 54 plus 29 is the same as 54 plus 30 minus 1. Only this is so much easier to do in my brain than this. If I do this, oh God, I gotta write it all out, line it up, and blah, blah, blah. It's so tedious. I don't feel like doing it, right? But I can to check. So we're just thinking, add friendly tens and then fix it, right? Break off some of the too many cubes. Right? If you add too much, you just subtract some back. If you add too much, you just subtract some back. And so notice, teachers, a few things. I want to just number this for you so you can be super crystal clear. 1, we do our compatible number thing. But once we do that, we model concretely, like cubes are in your hand and you physically break one off. Then draw the picture. Then write the equation. Then, right, set them up equal to each other and evaluate. Just to check and be convincing, right? And finally, you want a little chant just to jog our memories. Add too much, you gotta subtract some back, right? So now here, if I add too much, I want to go back to 28. I just subtract 2. What do? Let them help you, right? And so now, let them help you. They tell you what to do. Let's do these in our brains. Everybody, do this in your brain. You can do do this? Do this in your brain, and you're just practicing, right? Okay, ready? So we're going to choose a number, and we want to add 29. Let's do these all in our brains, okay? You're just going to write the answer on the whiteboard. Don't worry about drawing all the work, right? Great. They pick, 32 plus 29. Let them solve it in their brain, write down their answer, discuss. And then be like, okay, now let's write the equation we did in our brains. We did 32 plus 30 in our brains, and then we took one away. Cool. Okay, this is really amazing. Like, we're not writing equations and then solving, and we're writing the equations on teacher's row. We're solving and then writing the equations. Isn't that how math is supposed to work? Equations are supposed to represent the thinking we do. It's not that we just mindlessly write equations and then are number crunchers. So this can be really, really cool. And again, if we're stuck, we go back to the model. Like, well, which of these would you want to use? Would you really want to count out 29? No. Let's use our tens rod. It's great. Now fix the tens rod and make it 29. Oh, look at that. That's plus 30 minus 1. Cool. So that's that lesson. Now you can see that if you're not super good at adding 30 in your mind, this strategy is tedious. But they should be good at that because you practice that. And then you're just practicing.